Good evening, everyone. Today Shruti have joined. She is also a part of ExcelR. So Shruti is going to give you the guidelines that where you can find the recorded video and where you can get the material for the sessions. So Shruti will explain you everything. Just go through it very, what we can say, like, pay some attention to her. Okay, so she'll explain you everything. So Shruti, over to you.
Yes, hi Moon. Thank you so much. Yeah. Good evening, team. So I'll just walk you through the LMS platform where you can access the recording of your previous day, okay, and where you would be finding the material as well. So as of now, the material is not yet available to be uploaded. So once it is done, you can just refer the same in that particular folder. I'll just share my screen. My screen is visible, right?
Yes, Shruti. But Shruti, you're not audible.
Moon, yeah, okay. Okay. So guys, you will be logging in for this elearning.excelr.com. Once you log in, 1 second. Now am I audible, Moon?
Yes, Shruti, continue.
Moon, could you please stop the annotations from your end?
You have to do it
Someone
like,
is drawing something.
yeah. So once you share the screen, you get that three dots more option.
Yes.
So there you can disable it.
Yeah. 1 second. Yes. Okay. So my screen is visible, right, Moon? And am I audible?
Yes, Shruti. Yes, Shruti.
Okay. So guys, once you log in for this elearning.excelr.com, right, you have something called as My Live Classes. Okay. Just click on this My Live Classes. You have to go to the batch you're attending. So you're attending this everyday learning session. One second.
Shruti, again you are not audible.
Okay. So once you log in for this elearning.excelr.com, now, but network is pretty much clear from my end. Still, am I not audible, Moon?
Actually, there is a log in audio and
Am I
video
audible?
is streaming.
No. Okay. Now is it fine?
Yes, Shruti, continue.
Yeah. So, you have to go to My Live Classes. What is there on your dashboard? Once you go to My Live Classes, you have to click on this badge for which you have been enrolled. Just click on this. Okay. Then you have to click on this view recording, what is there. Okay, so I'll just click over here. One second. So I'll just click on this view recording. Then you can see the video. This is how you can check for the live recordings of your batch. And if any material is being uploaded, right, you have an option called as material over here. So once the material is uploaded, you will be finding it over here itself. Okay. If not here, you have an option called as my self-paced courses. Once the material is uploaded, we will let you know how it is being taken up. Okay. But for now, to view your recordings, log in for this elearning.excelr.com. After login, go to my live classes. Once you go to my live classes, click on the batch you're attending and you have to click on this view recording. You can see it over here. And if you're seeing this couple of bubbles, right, you can just, these bubbles will be cleared and only the particular recording will be present. Okay, we will just check it and upload it over here. This is how you can check. And 21st Jan, there was no session, so there is no recording available. So 24th Jan is there and 25th sessions recording also will be posted very shortly. Okay. So that's all. How to check your recordings. Munmun, you can just check it up. I'm done from my end.
Yeah. Okay. Thank you, Munmun. Sorry. Thank you, Shruti.
Yes.
Yeah. Okay. Fine. So we'll start with our regular session now. So today we are going to cover the part linear regression. So from now onwards, we are going to focus on few machine learning algorithms. Okay. So first algorithm we have, that is linear regression. So the basics for linear regression is a scatter plot. This is one more visualization which we are going to learn today. So here we have a scatter plot which is always going to be created between X value and the Y value. Okay, X value and the Y value. Now let's understand what is this X value and Y value. So scatter plot uses the dots to represent value for the two different numeric variables. So whenever you want to create a scatter plot, compulsion is both the columns or both the variables must be numeric. It can be discrete also, it can be continuous also, but mostly it is for the continuous, right? If you try to create it for discrete, you are just going to get dots in the particular line. Okay, so mostly we are going to create it for the continuous variables. Scatter plots are used to observe the relationship between the variables. Yeah, so here we have some data given, right? Two columns are there: temperature in degrees Celsius and ice cream sales. Now one variable is considered as independent and another will be the dependent variable. Now here, ice cream sales is dependent on the temperature, right? Ice cream sales is dependent on the temperature. So ice cream sales is the dependent variable. Dependent variable. And the temperature is going to be the independent variable. Is going to be the independent variable. So always your dependent variable is denoted as y and independent variable will be denoted as x. So your independent variable is also called as input variable is also called as predictors, which is denoted by X variable. And we have dependent variables, which is considered as an output variable, which is also called as an target variable, and which is denoted by Y, right? Which is denoted by Y. So the scatter plot generally created between two numeric columns, X and Y. We want to identify how much is the contribution of this X in predicting the Y value. So regression is basically used to predict the values, right? Predict the numeric values. So for that prediction, we first need to identify whether the input variable is useful for prediction of output variable or not. And that relation we can get to know once you create a scatter plot. Now here, using the same data, we have constructed a scatter plot. X variable will be across the x-axis, temperature. Y variable will be across the y-axis, that is ice cream cells. And near about 12 data points are here. So these 12 data points have been plotted over here according to the temperature and cells. Now this scatter plot is always going to give you three insights. The first insight is about the direction of the relation. The relation can be positive or it can be negative. Relation can be positive or it can be negative. If the data points are moving into this direction, we consider it as a positive relation. Right? On the other hand, if we have a data points moving into this direction, then we will consider it to be the negative relation between two variables. Now for positive relation, you can consider if X value increases, Y will also increase. If X value decreases, Y will also decrease. Okay, X value increases, Y will also increase, X value decreases, Y will decrease. So you can consider it sort of a directly proportional relation between X and Y. For negative relation, as I said, if we have the data points into this direction, you can consider it to be if X increases, Y will decrease. And if X decreases, Y will increase. So you can consider this negative direction is as inversely proportional relation between the X and Y variable. Now, second insight is strength of the relationship between X and Y. Strength of the relationship between X and Y. And again, there can be three values. Either the strength can be strong, or the strength can be moderate, or the strength can be weak. Strength can be strong, moderate, or weak over here. Now, how we can determine that? So, variation concept we have studied, standard deviation concept we have studied. So here, if these data points are having a slight variation over here, this variation is very low. So whenever we are having a small variation, very low variation, we consider this is a strong relationship because there is not much variation between these data points. So it's a strong relation. For moderate relation, you can assume the data point something like this. So I plot few more data points over here. So we have data points something like this. So in this particular case, you can consider that there is high variation between these points. So it is having a moderate relation. And if you get a scatter plot where the points have been scattered all over the graph, right? So you can consider weak relation or no correlation at all, right? So if there is no relation between your X variable and Y variable, it means that X variable is not useful for predicting the Y variable. If the two variables are not related, you cannot use independent variable to predict the dependent variable. That is the meaning over here. And after this, the third conclusion from this scatter plot. Yeah, so the third conclusion from this scatter plot will be about linearity of the data. linearity. Okay. Now, if I just try to imagine a straight line passing by these data points, if those data points are following a straight line path, so we consider it is having a linearity, right? What if we have the data points something like this? If we have the data points which are like this, so in that case, though I imagine a straight line passing by these particular dots, but the dots are not following the straight path. They are following the curved path over here, right? So whenever there is a curved path, we can consider it is non-linear relation. Not only the curved path, but apart from any graph, apart from any pattern, if we get, then we consider it as a non-linear data. Only if the data points are following the straight line path, we can consider it is a linear data. Okay, it is a linear data. So these three things we are going to conclude from our scatter plot. So now on the similar lines, we have another scatter plot, right? So we have number of cigarettes smoked in years by lung capacity over here, right? So lung capacity depends on number of cigarettes smoked. So this is Y variable, this is going to be X variable, right? And we try to plot these 5 points as the scatter plot over here. We are getting a negative direction. If I imagine a straight line, these points are following the linear path, so it is linear relation. And this relation is strong. Why I'm saying strong? Because there is slight variation between the values of this data point, right? So it can be considered as a strong relation. But still, if you are confused, like if you cannot understand whether it is a strong relation, moderate or weak from the graph, then you need to calculate correlation coefficient between your X variable and Y variable. Now let's understand what is this correlation coefficient. So correlation is a bivariate analysis that measures the strength of linear association between two variables, right, and the direction of the relationship. So it's a statistical technique used to determine the degree to which two variables are linearly related. And again, this correlation coefficient can be calculated between the continuous data only. If the two variables are continuous, then only you can calculate the correlation coefficient to find out the strength of the relationship. Now, this correlation coefficient is denoted as small r value. Its value ranges in between -1 to +1. Once you calculate correlation coefficient, its value is going to range in between -1 to +1. If we consider magnitude of r, I'm not talking about the sign. If we consider the magnitude of this r close to 1 or exactly 1, then we can consider it is a high correlation between two variables. High correlation means X variable is most useful for determining the Y variable. Okay, input variable is most useful for calculating the output variable. And if you get a correlation close to 0 or exactly 0, then you can consider weak relation is there between the X and Y variables. This is the formula, mathematical formula by using which you can calculate the small r value, correlation coefficient value. Now you can see in this formula, we are only consisting of X value, Y value, X bar and Y bar. So X and Y will always be given to you. For example, if you want to calculate it for this. So X is already given to you, Y is also given to you. X is given to you and Y is also given to you. Now, what is that X bar? X bar is nothing but average of the X variable. Okay, X bar is nothing but average of the X variable. And Y bar, we have average of the Y variable. As both the variables are continuous numeric, so we can easily calculate the average of it, right? By using mean function or mean formula. Okay. So we have this mean calculated. Substitute the X and Y value one by one into this equation and we can calculate the small r value mathematically. Now again, for the data scientist, nobody will ask you to calculate mathematically, okay, or manually. We have a function for calculating this. So I'll explain you that function after some time. Okay. So what can be the interpretation of that correlation coefficient value? So positive R indicates the positive linear association between X and Y variable, and negative R represents the negative linear relationship between X and Y variable. R is always in between -1 to +1. Strength increases as R moves away from 0 towards either -1 or +1. As I said, the magnitude, if it is close to 1, then we consider there is a strong strength. Okay. If this value is close to 0 or exactly 0, we consider there is no strength at all between the two variables. Extreme values, that is +1 and -1, indicates the perfect linear relationship. So if it is +1, we consider it is perfect positive linear relationship. And if it is -1, we consider it is perfect negative linear relationship between the two variables. Now some graded interpretation is there, like for which value we should consider it as a weak relation or moderate or strong. So again, this is not a thumb rule. This is just the industry standard use. You can change this particular range according to your interest, right? So here, if the magnitude of R is in between 0.1 to 0.3, we consider it to be a weak relation between two variables. If the magnitude is in between 0.4 to 0.7, we consider it to be a moderate relation. And if it is between 0.8 to 1, we consider it to be a strong correlation between the two variables. I'll give you a few examples over here. Suppose the R is equals to minus 0.74. Suppose it is equals to minus 0.74. So from this value, we can first determine that it is having a negative relation, right? And according to ourselves, like we can, these values, this range is subjective over here. So according to the data available, I can consider it to be as a moderate relation, right? Suppose the R value is equals to plus 0.97. So in that case, I can consider it is a positive relation and it is going to be strong relation. Strength of the relation is strong over here. So in our data, so according to this, as compared to this value, this 0.74 we'll consider as moderate. If we don't have this particular value, then if this is the highest value, then accordingly we will consider it to be a strong relation. So that is completely subjective. You need to take that decision whether it is moderate or you are considering it to be strong relation. Okay. Now, these are few diagrammatic interpretations about your correlation. So if your correlation value is equals to +1, so as I said, it is going to be a perfect positive relationship. This is how the graph will look like. All the data points are on the straight line, right? And into the positive direction. Okay, so this is a positive correlation. More the X value, more will be the Y value, less the X value, less will be the Y value, right? So sort of a directly proportional over here. Next, we have P is equals to -1. If we consider P is equals to -1. So in this case, we'll consider this graph, right? So here we have negative relation from this value and it is 1. So it's a perfect negative relationship. All the data points you can see are belonging to the straight line over here, right? So negative correlation, more the X value, less will be the Y value. Less the X value, more will be the Y value. So this you can consider as an inversely proportional relationship. Right? About moderate relations, you can see it like this. Okay. So if moderate correlation is there, 0.7, we'll consider it to be a positive moderate. So all the data points are moving into the positive direction and they are having moderate relationship. You can see few variations over here between the data points, right? So according to that, it is the moderate positive relation. Same goes for your negative value also. So if it is minus 0.7, so minus determines negative direction. All the data points are moving into negative direction, downward direction basically. And 0.7 determines the strength. So it is moderate. Right? Data points we can see which are having like variation over here, right? So this is considered as negative moderate relation. And lastly, after you create a scatter plot, if you get a graph something like this, so you can determine no relation at all. So your correlation coefficient will be equals to 0 or close to 0, which determines no relation. Doesn't matter whether x increases or decreases, it has nothing to do with affecting the y variable value over here. So that is the meaning of no correlation at all. So coming back to our example of cigarette smoked and lung capacity. So if we want to investigate the relationship between cigarette smoking and lung capacity, right? So we have a data where sample group response data on smoking habits and measured lung capacity respectively is provided. This was the data. Right? Before some time, we have considered the same data. So from this, we have constructed a scatter plot. We can get an idea that these points are moving into downward direction. So this is negative relation. Strong or moderate relation, we don't know. And about linearity, yes, these data points are linear. Now, after calculating the correlation coefficient between your cigarette smoked and lung capacity, we have received the R value as equals to minus 0.96. We have received that R value to be minus 0.96. So minus represents negative relationship. 0.96 represents that it is a strong relation. Okay. So minus 0.96 implies almost certainly smoker will have diminished lung capacity because there is a strong relation and it is negative. Number of cigarettes smoked increased, lung capacity will decrease and vice versa. So this is how from the scatter diagram, first we need to identify what is that relation between the two variables. Okay. Okay. So is this understood so far? Basics of scatter plot and how to read it. Okay, we have one question. Somebody is asking like, what is this R? So as I have explained just now that R is correlation coefficient. Okay. So which is calculated mathematically by using this formula. In Python, you can use a function called as CORR and you pass the data. So in those two variables, we'll get the correlation coefficient calculated. Okay. So this formula of R consisting of X value, Y value, X bar and Y bar. So here if we consider the same data, right, we have the X values given to us, we have Y values given to us. From this, we can calculate X bar, we can calculate Y bar, we can manually substitute it into the formula and we can get this small r value calculated. Small r value ranges in between +1 to -1. Right? So if value close to 1, either plus or minus, strong relation. And if that value is somewhere close to the 0 value, then we can consider no relation or weak relation between X and Y. Is it okay? The person who have asked me about R. Okay. Now we'll go ahead with this regression concept. Right. So is regression analysis plus correlation, which is used to predict the future performance of the past using the past results. Right? So, while correlation only explains the degree of linear relationship between the two variables, regression defines that relationship more precisely. And regression analysis is a tool that uses data on a relevant variables to develop a prediction equation or a model. So it is creating an equation. By using that equation, you can predict the value for the unseen data or for the new observations. Now let's understand what this regression is and why it is used. For example, consider same example over here, lung capacity, right? Now here I have 5 records, right? 5 rows are there, 5 records are there. Using these 5 records, suppose we have built a model. Now that model is built in such a way that suppose there is a 6 data provided to you, right? And where cigarette smoked, I'll mention it as equals to suppose 30. Cigarette smoked will be equals to 30. Now, what is your model's job or what is your job? That if the input variable is provided to you, X is our input variable, right? That is the independent variable. So that will always be provided to you. Using that, apply your model, and then you should be able to predict what will be the lung capacity if person is going to smoke 30 cigarettes. Okay. So this is how you are going to predict for the new observation for the unseen data. So you are building a model based upon the given data to predict for the new incoming data, new observations, new unseen observations over here. So to achieve this objective, we are going to build the regression model. Now, here we are mostly talking about equation. So what that equation of regression? An equation. Y is equal to beta naught plus beta 1 x plus epsilon. The equation for your simple linear regression. So simple linear regression is useful for finding the relationship between two continuous variables. So as I have already said, simple linear regression is only applicable when the two variables x and y both are continuous, right? X and y both are continuous. Yeah. One is a predictor, which is an independent variable, which is nothing but your x variable. And other is an response or dependent variable, which is your y variable, right? Now, there is one query in the chat that if we have multiple x values, then which x value we are supposed to provide. So I'll first explain you about the simple linear regression, then I'll explain you about the multiple linear regression. Okay, so hold on for some time. I'll get back to that particular question. So it looks for statistical relationship, but not deterministic relationship. And how it is calculated? So we have this formula, right? Y is equals to beta naught plus beta 1 x plus epsilon. So let's understand this equation first. So we have equation y is equals to beta naught plus beta 1 x plus epsilon. So x is already provided to you, the given data, the independent variable. You need to predict this y variable. So this is mostly predicted value is denoted as y hat. Okay. Predicted value is denoted as y hat. Beta naught is considered as an intercept. Beta 1 is called as coefficient. In general terms, even beta naught can also be called as a coefficient over here. And epsilon is considered as error term. Epsilon is considered as error term over here. Now we have a scatter plot. We have x values over the x-axis, and we have y values over the y-axis. And we have the points, something like this. So these are the points we have for our scatter plot, for example. And we have a model. Suppose I consider that model something like this. This is going to be the model, right? Which is represented by this equation. Right? Now, as I said, linear regression. So it is going to be a straight line, and you can compare this equation with the equation of straight line, which is nothing but mx plus c, which is nothing but mx plus c, in which you can consider this beta naught as some constant. Beta 1 is the slope of this particular line. Same way, what is this beta naught? Wherever your model intersects the y-axis, that is called as an beta naught intercept. And the slope of this particular line is nothing but the beta 1. Slope of this line or model is nothing but the beta 1 over here. So once you get the value of beta naught and beta 1, you can substitute into this equation and you can get the predicted y value calculated. And now what is this error term? So error, which is equals to actual value minus predicted value. Okay. Error is generally represented as epsilon, which is nothing but actual value minus the predicted value. Now over here, if I consider this is as an actual value, right? This is as an actual value. I mean, all these blue colored data point, let me just change the color. Okay. All these blue colored data points are nothing but the actual values, right? That is the given data. Okay. Actual y values basically. When you calculate a perpendicular distance, right, with your model, right, and wherever it intersects on your model, that becomes the predicted value. So this pink colored one is nothing but the predicted value of y by using this model. Okay. So this particular gap between your actual value and predicted value is considered as an error. Is considered as an error. Or generally we call it as a loss also, loss of that particular model. Same way for all the data points, when the perpendicular distance with the model will be calculated and get the average of it, we'll get the total error made by our model. Okay, if we average the errors made by all the data points, we'll get the total error of your model. Now, whenever we talk about error, right, about anything, right, we talk about error or loss, we want that value to keep minimum possible. Okay, ideally we expect that error to be equals to 0. Okay, if you get error equals to 0, how your model will look like all the data points or on that particular model itself, then only the predicted value and actual value will have 0 difference. So overall error will also be equals to 0. Practically it is not possible to get 0 error, but we try to keep it minimum possible. That is the only criteria. How can you determine your model is working correctly if the error is minimum possible, right? So we'll keep that error to be minimum possible. This is how your equation will be formed. Y hat equals to beta naught plus beta 1 x plus epsilon. Now, if we consider this epsilon to be minimum possible, let's just ignore that and we'll focus on the equation y hat equals to beta naught plus beta 1 x. This is going to be the simple linear regression equation over here. Have you understood this part, this slide over here? Okay. Now, in the same slide, I'll just explain you about. Okay, I'll just repeat it one more time. So, as I said, like very firstly, whenever you go for regression, you firstly need to construct a scatter plot. Okay. So we have created a scatter plot over here. You can see on the screen. And we need to create a linear regression model. Now that linear regression model must be in such a way that the overall error will be minimum. So that means that model should be close enough with all the data points, right? That model to be very close to all the data points over here. And the equation of that linear regression will be beta naught plus beta 1 x plus epsilon over here. So we have this beta naught called as an intercept, beta 1 as an coefficient, right? X values are already provided to you in the data. Epsilon is the error term. So as I said, it is a linear regression, right? So a straight line model will be created. Straight line equation we can represent as y is equals to c plus mx, right? So mx plus c basically, right? I have just changed the position over here, in which m will be the slope. Same way, beta 1 is going to be the slope of that model line. C is the constant. So same way, beta naught is considered as an intercept. So that intercept is wherever your model intersects with the y-axis, that becomes the beta naught value. It can be positive or negative or any value, okay? When you build a model, you will come to know about that beta naught value. And for beta 1 also, you will get the value once you build the model. Now for error, error is the difference between your actual value and the predicted value, right? For example, assume I have two columns over here. Like suppose I want to predict the age. Suppose I want to predict the age. So this is the given y value and I have the predicted y hat value and I want to calculate the error between them. Here we have the actual value of age for the first record is given as suppose 25 years. For the second, if it is given as equals to 31 years. For third one, it is given as, for example, 45 years and something like that, right? And using my model, I have predicted the values of the age, right? So predicted value I have as 26 years old. Predicted value for the second record is equals to suppose 29, and for third record, if it is equals to 44, the predicted values, right? Now, how much is the difference between your actual and the predicted value is nothing but the error calculated. So if I just take it like this, and for the time being, for simplicity, I'll consider this difference to be the absolute value. This is modulus, okay? This is used for modulus over here. So I have considered it to be the modulus value. So here the error will be 1. Here the error is going to be 2. Here the error is again going to be 1. So likewise for all the records, error is calculated and when you take the average of these errors, it will be the total error of your model. Now this total error, we want it to be minimum possible. Total error, we want it to be minimum possible over here. So that's the equation, guys. Those who asked me to repeat, now is it clear? One question is that like, do we need to calculate the error by considering the points on the graph? No, no. Again, we have a functions to calculate these errors over here. You don't need to separately calculate it. I mean, by using a graph or by using pen and paper, we don't need to calculate it. Okay. So once we have understood this equation, we have an example like this. Suppose you want to calculate the used car cost, right? So equation will be, can consider it as a beta naught plus beta 1 miles driven. So miles driven will be your x value plus the error, right? So same equation can be represented like this also. Now, how the best model can be chosen? So let's understand. Suppose we have a data, experience and salary. So salary depends upon experience. Okay. Salary depends upon experience. So experience become your x variable across the x-axis. Salary becomes the y variable across the y-axis over here. So this is a scatter plot created over here, right, for these 10 records. And can you tell me whether it is positive or negative? Exactly, it is positive relation because the direction is like this, right? Then can you comment about strength of the relation between x and y, whether it is strong, moderate, or weak from the scatter plot, if you can determine? It's a strong relation, right? It's not at all a weak relation, guys. It can be a moderate or strong, but mostly if you see the variation between these data points is very small, right? So you can consider it is a strong relationship over here. And the third thing, linear or not. So again, if I just imagine a straight line passing through these data points, are these points following a straight line path? Yes, so they are along the or across the straight line over here. So we can consider it is a linear relation over here. Okay. So what does that mean? When you conclude it from this scatter diagram, it means you can definitely use experience to predict the salary y hat, right? You can definitely use the experience to predict the salary. If the relation would have been weak, then we would have concluded that experience is not at all useful to predict the salary. Then we need to ask for another data or more data, okay, to predict the salary over here. Okay. Lipsa is saying that linear part is not clear. Just try to imagine a straight line passing through these data points. Are these data points forming a curve, or they are forming any sort of design or pattern over here, Lipsa? Or they are just following the straight line path across the straight line path? So straight lines. So that means there is a linear relation. Or otherwise, you can just conclude if x is increasing. Like for example, if I consider x is equals to 10, right? So y is also increasing. Then if x is equals to 10, y is near about 80, right? So y is also increasing. If again I increase the x value to 14, so y have been increased to near about 150. So if x increases, y increases over here, right? And they are on a straight line across the straight line. So there is a linear relationship between these variables. Okay. Okay. So far we have not built any model, so we cannot comment about the model. We are just talking about this data, the relation between these data, whether it is strong, moderate, or weak. We have not yet created the model for this data. Okay. We are just trying to identify first whether it is useful for predicting y variable. If this is not at all useful, if you get a weak correlation, suppose you get a graph something like this where all the data points are scattered over the plot, how can you use this x variable to predict the y variable if there is no relation? To build a linear regression, we'll require a relation between x and y. Okay. So for that purpose only, first we need to construct a scatter plot. Okay. Okay. So this dotted line you can consider as a model generated. Okay. You can consider it to be as a model generated over here. how we have constructed it, I'll show you when we'll do the implementation. Fine. Now it's almost 7. We'll just take a break for 10 minutes now, and then we'll proceed with this example and its implementation. Okay. So break for 10 minutes. We'll reconnect by 7:12. Okay, let's continue. So this we are going to build the model for. So problem statement will always be given to you like this as an business objective. So it says in order to investigate the feasibility of starting a Sunday edition for a large metropolitan newspaper. So information was obtained from a sample of 34 newspapers concerning their daily and Sunday circulations in thousands. So from this problem statement only, we can determine that, okay, we want to investigate if you start a new Sunday edition. So from this statement, we can determine daily circulation becomes your X variable, Sunday circulation becomes the Y variable. Because we want to investigate the feasibility of starting an Sunday edition. So daily circulation of that newspaper will be provided to you. You want to predict it for the Sunday circulation. It's like, for example, 34 newspapers details have been given over here. There will be a 35th newspaper as some named as ABC. And if I provide you the daily circulation for 500, so 500,000 newspapers are getting circulated if it is a daily edition. Right? For this newspaper ABC, if I want to start Sunday edition also, now whether it is going to be a profitable or it will be in a loss, what if you already predict what will be the Sunday circulation, you can determine whether to start a Sunday edition or not to start Sunday edition. Okay, such type of decisions can be made once you apply such type of model, regression model, okay, for prediction purpose. So using this 34 newspapers data, you need to build a model so that it can be reliable on new observations, unknown data. Newspaper name is anyhow not useful because it is not contributing anything for identifying the Sunday circulation. So we can completely ignore that column for the time being, and we can just consider X variable as daily circulation, Y variable as Sunday circulation. Now, whenever you get a data, the very first task is identify whether this X variable is useful for prediction of Y variable or not. And that you can do either by constructing a scatter plot or by finding correlation coefficient between your X and Y. So let's consider a scatter plot over here. So we have a scatter plot, daily circulation X-axis, Sunday circulation Y-axis, and we have the points mentioned over here, right? 34 points have been plotted over here. Now it is positive direction, right? It is a strong relation we can consider because low variation is there, right? And we can also consider it is a linear relation because if I just assume a straight line, these data points are across the straight line. So we'll consider it is a linear, positive, and strong relation between daily circulation, Sunday circulation. From this, we have concluded that daily circulation data is useful for finding out the Sunday circulation. If we would have received low correlation or weak correlation, we would have concluded this data is insufficient. We'll require some other data, right? Likewise. Now here, suppose two models have been constructed. For example, there is the first model and this is the second model. Now, based upon this straight line over here is nothing but the model, right? Same way, multiple models can be created. Out of all these models, Sanika is saying if the relation is negative, that's okay. Negative relation, it's not like no relation, right? Negative relation is okay. Everything will be same, no change. Fine. Yes. So here we were talking about multiple models can be generated, out of which the best model will be identified. Right? Best model will be identified. How the best model will be identified by that function? Based upon the error. So the model which will give you minimum error will be considered as the best model. So here, just for instance, we have two models generated. If you see for the second model, most of the data points are having such a large error. Like assume this is a perpendicular distance calculated. So these distances are very high. So overall error will also be high. And for this first model, you can see data points are having very small distances over here, right? These data points are having very small distances. So overall error will also be minimized over here. So out of these two, the best model will be this first model having minimum error, right? Because it is having minimum error. Okay. Now, according to our equation of linear regression, y is equals to beta naught plus beta 1x plus epsilon. In our example, in our example, the equation will be, we want to predict the Sunday circulation. So equation will be beta naught plus beta 1. X is in our case daily circulation, daily column, right? And we are having this epsilon, okay? Now, mathematically, how to calculate beta naught and beta 1 value. Okay. So, beta 1 first will be calculated. There is the formula. We have yi and y bar. So, yi is again the y values given in your data. Y bar is the average of y values. Xi minus x bar. So, xi is every given x value from the data. X bar is the average of the x values and divided by summation of x minus x bar whole square. So just substitute y, x, y bar, x bar. You can get the value for beta 1 mathematically. And when you use that beta 1 value, you can also calculate the beta naught value. So for beta naught, the formula will be y bar, which is average of y, minus beta 1 value x bar. X bar is the average of x values. Few questions in the chat window, how to generate this equation. We are not going to generate this equation, okay? This is the equation generated by researchers, statisticians for linear regression. Yeah, use of this equation, I'll show you after some time, fine? And Kalyani is saying something about Sunday edition and some values over here. So no, that sort of interpretation will not be there from the scatter diagram, okay? How to plot a scatter diagram? I'll show you the function. Yeah, good question, Nabil Sheikh. Yi, is it a single value? No, this I represents index values. I mean, multiple values basically. So this equation, it can be like summation. That means y1, the first y value minus the y bar. Okay, multiplied by x1 minus x bar plus y2 minus y bar multiplied by x2 minus x bar and so on. So wherever this I is represented, that means each and every value from your data one by one. Okay. Now, so manually or mathematically, so far we have first seen the scatter plot or the correlation coefficient. We have determined that daily circulation is useful for predicting the Sunday circulation. After that, we have created this model also. Now, once you create a model, you need to determine whether your model is working correctly or not. For that purpose, what you can do, you need to calculate coefficient of determination, which is nothing but r square, capital R square. There is a change, capital R square. Okay, it is a capital R square. Capital R square value ranges in between 0 to 1. If this value is generally greater than 0.85, we consider our model is going to work correctly. Our model is going to work accurately. Or you can even consider it like this. If R square is greater than 0.85, that means the error have been reduced. That can also be the interpretation. So separately, you don't need to calculate the errors. Either one value you calculate and you can determine whether it is working correctly or not, right? So we will determine it with the help of R square in case of your linear regression model. So it should be greater than 0.85. Then we can consider your model is correctly working. Again, this R square value, you don't need to separately calculate. When you look for the summary of your model, you will get that R square value also calculated for you. Right? Now let's perform that into Python. And after performing it, this is how the output will be displayed to you. And everything is calculated over here. Whatever we have studied so far, everything is calculated. Such type of small table will be given as an output. Let's understand this table and then we will see the implementation in Python. So first we have intercept and the daily mentioned. So this intercept is nothing but your beta naught, and for daily it is going to be the beta 1 value. This is the value of beta naught and this is the value of beta 1. Now using these values, how the equation will be? So predicted y value will be equals to beta naught. So at the place of beta naught, I'll place 13.84 plus beta 1. So beta 1 is calculated as 1.339. So I'll just consider it as 1.34 x value. And epsilon is minimum, so we will ignore it, right? So this is going to be the final equation for predicting the Sunday circulation over here. Now some test statistics have been performed from that hypothesis test. So you will get this p values calculated over here. Just ignore it for the time being because that is not going to give you any interpretation of the output. And let's concentrate on these p values. Now again, these p values are the probability values calculated. Now these p values has something to do with the alpha value, right? Last session we have studied hypothesis test, right? So if we get this p value less than or equals to alpha 0.05. Now again in our problem statement, alpha is not given, so we will assume it to be 0.05. So if this p value is less than 0.05, then we can also consider that input variable is useful for prediction purpose. So multiple ways are there to identify whether there is a contribution of input variable for predicting the output variable or not. First, scatter plot. If there is a strong relation, then you can include that input variable. Second, correlation coefficient. Or third one, you just randomly build a model and then you look for the p-value, whether it is less than 0.05 or not. Now for intercept, we are not going to look it because this is calculated for the output variable only. We'll look it for our input variable. Now in this case, this value is definitely less than or equals to 0.05. P-value is less than 0.05. P-value is less than alpha value. That means chance of making error if you include this variable is less than 5%. Definitely we'll include it. We will take an action. We'll go with alternate hypothesis. Okay. So let's take an action and include the daily circulation in building the model. So that means this input variable is useful. So these values are mentioned over here. Along with that, you need to look for multiple R square value. Okay, you need to look for multiple R square value. So here we have multiple R square value as 0.91. What we have considered this R square value to be greater than 0.85. And here we have that value greater than 0.85. That means the model which we have built it is the best model possible, which is having maximum accuracy and minimum error value over here. Apart from that, few other values are given like adjusted R square value. There should not be much difference between your multiple R square and adjusted R square to determine the model is best model. And some F statistics, degrees of freedom, p value for your overall model are also calculated. But out of all these values, we are mostly interested in getting coefficients, getting p-value less than 0.05 and getting this multiple R square value greater than 0.85. This is how you can read the output of your model. Now here, let's understand our model. So I have just written the equation. And I'll go back to the data. So here we have a data. I have written this equation wrongly. I would have mentioned it over here. Okay, y hat is equals to 13.84 plus what was it? 1.34 x value. Now, using this equation, we can solve it for each and every record. For example, for first record now, Baltimore Sun is the name of that newspaper. We know the daily circulation over here, right? We know the daily circulation. So this being your x value, let's substitute into the equation. So here if I substitute that x value as 391.952. When you solve it, you will get the predicted value of Sunday circulation for your first record. So you'll get a y hat value. Okay. And manually, like, just for your confirmation, you can just cross-verify the predicted value and the actual value. There will not be much more difference between these two values. Okay. Yeah. I did get this question. Like, can you come up with the appreciation of the equation? So I didn't get this question. Like, what exactly you want to ask? Okay. Same way, like if you want to calculate it for the second record, then you just substitute this x value at the place of x value over here, and you will get it calculated for the second record. For example, I'll mention it to be 516.981. And when you solve it manually, you will get the predicted value of second record over here, right? Predicted Sunday circulation for the second record. So quality of prediction is good or not, that's what we have determined from the R square value. R square value is used to determine whether your model is working correctly or accurately or not. Okay. So have you understood like how this equation is going to help you out for predicting the values manually? I think few people missed the attention in between. So those are asking me like from where we have got these values and all, how to get the beta naught and beta 1. Okay. So let me just revise it once. Once you build a model, you will get the output like this. From this output only, we have identified the beta naught. Always the intercept is your beta naught. And for daily circulation, we have the beta 1 value calculated. So by using these values, substitute it into the equation. What was the equation? Equation was y is equals to, what is beta naught? 13.84. What is beta 1? 1.34. And x. So after substituting these values, right, we got that equation. Okay. Yeah. So those who have not understood like how these values have been calculated, is it clear now? Okay, fine. So for the same data, now we'll see the implementation. Okay, using Python. So first of all, we need to import the data. So as I have explained you, first you can upload the file and then you can just give the name of that file to import it. Or you can even give the location over here and you can import it, right? Either way. So we will first import pandas as PD because without that, we will not be able to use the function read underscore CSV. Now from pandas, use function read underscore CSV, give the file name, import that into some variable. I have given the name as data. Now go for some basic analysis like just apply head function, right? You can apply describe function. You will get some descriptive statistics. You can apply info method. So this info method will give you the output like this. So it says that there are 34 entries, 0 to 33. That means 34 number of rows are there in the column. These are the three column names, newspaper, daily, and Sunday. And we have the data types mentioned over here as an object or float type or what. And we are getting if there are any missing values, if there are any blank values. So we don't have any blank value because all the 34 are non-null values over here. So just as a basic idea about your data set, you can perform this. After that, we need to check whether the input variable is useful for predicting output or not. So either we'll go for scatter plot or we'll go for correlation coefficient or we'll just build a model and then we'll look for the p-value. So either alternate way you can use. Here I have gone for correlation coefficient. So I can use the name of my data set, that is data. We have imported it into a data name variable dot CORR function. So this CORR function will create a matrix in which the correlation coefficients can be calculated. So for example, you can consider we have a matrix. We have daily and Sunday row wise. We have daily and Sunday column wise. Diagonally, we have the value as equals to 1. That means perfect relationship, perfect positive relationship. Why we are getting it 1? Daily to itself, 100% correlated. Sunday to itself, 100% correlated. For this matrix, above the diagonal and below the diagonal, you are going to get this equal value. So either you can refer above diagonal or below diagonal values. Here, the relation between the strength of the relation between daily and Sunday is equals to 0.95. Relation between daily and Sunday is equals to 0.95. So 0.95 is positive relation because the sign is positive and it is a strong relation between two variables. So we have just not mentioned X or Y. We have just applied this CORR function on the complete data. So as I said, CORR function will only be applicable for the numeric column. So as you have stored your data in a data variable, out of all these three columns, that CORR function will come to know only daily and Sunday are the numeric columns. So it have calculated the correlation for those two columns only. You don't need to pass the data separately. Okay, you don't need to pass the data separately over here. Okay. Yes, Nabil Sheikh. Yeah, okay, okay. So from this, we have concluded that daily circulation is useful for predicting the Sunday circulation. Now let's build the model. Okay, let's build the model. So there is one package called as stats model. From that stats model, we are just accessing the libraries formula.api. And it's a huge name over here. I don't want to use this huge name, so I just name it as SMF. Any short form you can give. No compulsion about giving this short forms over here, abbreviations over here, but generally for statsmodel.formula.api, we use SMF. Okay. After we import it from that SMF, a function called as OLS, ordinary least square. Okay, ordinary least square, which is used to perform linear regression. Okay, this is used to perform linear regression. So SMF.OLS, and the syntax will be y tilde x. Y tilde x. Now y is nothing but name of the y variable, column name, okay, in which you have y variable. And x is nothing but the name of your x variable, independent variable. So according to this logic, we have mentioned Sunday. Now, this is case sensitive. In your data, you have a Sunday column. You can see in your data, you have a Sunday column, everything lowercase. So you need to mention same way. If you change it, you will get an error. Okay. Same way for daily circulation, we have the daily as the column name. So the same name we are going to use in our model building. So let me build a model over here. So we have considered Sunday till the daily. Always y variable till the x variable. From which data we should get this Sunday and the daily columns? So the data which is equals to data variable. This data is representing your data set which we have imported. Okay. And this data, this is the keyword. You need to use it as it is. This is a keyword to represent your data set name. You need to use it as it is. So data is equals to data. Now we want the best model. As I said, multiple models can be created, but we want the best model which will give you the minimum error. So for getting that best model, always we will use the function fit. So this fit keyword will determine out of all the models generated, we want the best model. Now this we have created and stored into a model named variable. This internally is going to create that particular equation. So you don't need to separately create it, right? This function, when you write down, it will internally create such type of function, okay? And we have stored that model in some variable. Now we just wanted to see like how is the scatter plot and how the regression line have been created. So from Seaborn library, as in the introduction of Python, I told you Seaborn library is used for advanced visualization. So you need to first install it by using pip install Seaborn, and then you can import that library whenever you require. So import Seaborn as SNS. Again, this name, generally industry standard. You can use any other name for Seaborn also. Now from that SNS, I am using a function called as regplot, which is used as an regression plot. Okay, reg plot stands for regression plot over here. So as we have mentioned, y value, so y-axis the Sunday circulation. So again, this daily and Sunday are the column names. It's a regression plot. Reg plot is regression plot, right? So x-axis will be the daily column, y-axis will be the Sunday column. And again, from where you should get the daily and Sunday? From our data named data set. Okay, from data named data set over here. When you execute it, we'll get this graph generated. Right. Now in this graph, you can see, as we have mentioned, x-axis is the daily circulation, y-axis is the Sunday circulation. And we are getting this straight line created over here. Okay, this solid blue colored line, this is our model generated. Now, because of this fit keyword, we are getting a best model generated. Otherwise, similar models can be generated within this shaded blue colored region. You can see this shaded blue colored region. Within that region, any model should have been generated. Right? Any model would have been generated over here. So that's the regression plot. Basically, this is optional. You don't need to create it every time, right? You just need to build a model like this. Okay. Now, to get the coefficient value, to get the R square value and everything, you can just apply a summary function on your model. Okay. You can just, you can just apply a summary function on the model. Now, model is what? In which you have created that OLS Sunday till the daily and so on, right? So that model created. This model created. Okay. For that model, I'm applying the summary function. So here we have the result of summary function. Everything is mentioned over here, like what is your dependent variable, right? How much is the R square? We are interested in this R square. It must be greater than 0.85. It must be greater than 0.85. Then apart from that, so many statistics have been generated. Then we have this coefficient and all, right? So we have this beta naught and we have the beta 1 calculated over here. Then we have this p value. From that p value, we are interested in this p value of the daily. Is this less than 0.05? Yes. That means you can use the daily for predicting the Sunday circulation. Okay. Difference between R square and adjusted R square, or this R square is also considered as multi R square, right? Or adjusted R square. So you won't see any difference over here when it is a simple linear regression. But if you go for multiple linear regression, in that case, if you add or remove the input variable, R square value will change a lot, but it will least affect the adjusted R square value, right? So that's the main difference between R square and adjusted R square value. So after looking for this particular summary, right, now we can use our model for prediction purpose. And why we are using it? Because our objective have been satisfied. We are getting the R square greater than 0.85. That means we are getting the best model possible. So here we can use it for prediction purpose. How we can predict it? So you can use the name of model. We have stored it into a model. You can use the function predict. So for predicting the values, you can use a function predict, and then you can pass your data on which you want to predict this particular value, right? So from your data, this model will automatically access the values of daily circulation, daily column, right? And it will give you the predicted values of your Sunday circulation, Sunday column, okay? So these are all the 34 values of Sunday circulation to be predicted over here. So this is how you can build your simple linear regression. You can use it. You can check for the summary. Manually, you don't need to do anything. You just use a predict function and you will get the output generated. So is this part clear? Is there any doubt so far? No, it is not predicting the profit. It is predicting you Sunday circulation, guys. Y variable it will predict for, right? So in our data, Sunday circulation is the Y variable. So it will predict you the Y variable basically. So for your first record, this is the predicted value. For second record, this is the predicted value for Sunday circulation. Okay, what can we decide from Y? So basically from this Y, we cannot decide anything. But if you apply your model for the new data, for example, I am just creating a new data frame over here. So first of all, I am creating two values in the series format, storing it to the new data named variable. Now that new data, I am converting it to the data frame format. So I'll get it in the tabular format where the column name, I want it to be daily. It's the same column name as of your original data. After you store it to a variable and display display it, we have received this. This is what we have generated. We have considered two values as 200 and 300 under the column daily. So basically what I'm doing, suppose I have received the new data as 200 daily circulation and 300 daily circulation for two new newspapers. And we want to decide whether to start for the Sunday circulation or not. So I will just use our model, which we have built it before some time. I will predict it on new data underscore pred. And here I have received Sunday circulation for the two records. So if the daily circulation is 200, Sunday circulation will be 281.77. If the daily circulation is 300, the Sunday circulation will be 415.75. Accordingly, we can make a decision if we are working for that publication, newspaper publication house. So we can take a decision that, okay, if for daily, if this much is the sell of the newspaper, for Sunday definitely we should start the edition, because the sell is more, ultimately profit will also be more when you start the Sunday circulation. So such type of decisions can be made then. So Prashant, this is not data analysis. We have actually built a model which can predict for the unknown data. Okay, so this is data science. Analysis is just this much. If you talk about analysis of your data is only this much. Head of the data and info from that data. Here we have not applied anything. Just from original data, we are extracting the values, right? So this is just an analysis. After that, whatever we have done, everything is data science. Okay. Yeah. Fine. Now, just as an overview, let me tell you about multiple linear regression. So just as an overview, okay. So in case of multiple linear regression, your equation will be modified like this. Like for example, y will be equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on. Plus epsilon, obviously, right? But that epsilon is like minute, so we'll just ignore it. So this is going to be the equation. Now I'll give you one example. Suppose I have age column, I have work experience column, and I have um, previous salary sort of thing, previous salary of the employees. So I have three columns over here. I'll just name it as X2. I'll name it as X2, and previous salary will be the X3 over here. And now my Y variable, I want to predict the current salary, or what can be the salary provided to that particular employee at the time of hiring that employee, right? So I have the first record over here. I have first record where I have the value age as equals to 40, work experience is equals to suppose 17 years, and previous salary monthly we'll consider, suppose is equals to um, 3 lakhs. So what can be the predicted salary for this employee? So for example, current salary of this employee is equals to 4 lakh per month, assume. Then we have second employee whose age is equals to 25. Work experience is only 2 years. And current salary is, for example, equals to 50,000. And now the salary have been increased to 60,000, current salary, right? Likewise, we have the details of employees for near about 100 employees. Assume we have details of the 100 employees. Now, you want to hire new employees, right? And you want to take a decision that how much salary should be given to that particular employee. Now, if you have actual model ready with you, what you can do? You can just enter the details about age as X1. You can enter the details about work experience for X2, and you can enter the details about the previous salary for the X3. Now you build a model using the similar command, and you will get this beta naught, beta 1, beta 2, beta 3 calculated, and you can substitute values and get the predicted salary for the new employee. So that, after giving a higher package, being HR, you will not regret that, okay, I have given a lot of package to this particular employee, does not worth it, something like this. Or maybe you should not regret after giving a low package to an employee, that, okay, I would have given some large package to this particular employee, but by mistake, by wrong analysis, I have given a wrong CTC to that employee. This should not happen. To avoid it, it is going to help your business that, okay, this is going to be the predicted salary. Okay, you know it. Accordingly, you can make an offer with that employee. Accordingly, you can negotiate with that particular offer. If for the new employee, the predicted salary is 50,000 per month. And if that employee is asking you for 1 lakh per month, you will straight away say no, because it is nowhere close to your predicted salary, right? Now, how you can build a model for multiple linear regression? I'll just give you an idea over here, right? Everything is going to be same. You will be importing your data, any data where there are multiple input columns, numeric input columns. After that, sorry about this. Yeah, after that, same way, you will just pass a correlation function on your data, and you will get a matrix created for the correlation values. And after comparing those, you will decide which input variables are useful. Using them, you can build a model here. So in this case, it is going to be smf.ols in bracket y variable name till the name of your x1 column plus name of your x2 column plus name of your x3 column. And then whatever is the data, you will pass it over here. You will use the fit function. Rest of the things are same. And your multiple linear regression model will be generated. Okay. So rather than passing a single input variable, you will pass multiple input variables separated by or joined by plus sign, and your model will be generated. Rest of the things are same, and same way on your model, you can look for summary. In that case, you will get coefficients calculated for all the input variables like beta naught, beta 1, beta 2, beta 3, and so on. And same way, you can just use that model. You can use a predict function on that data, and you can predict it for the new incoming observations. So that is how you can build your multiple linear regression model. Okay. Only slight change while passing the data. When you build a model, you need to pass multiple input variables. Here you need to pass multiple input variables joined by plus sign, and your model will be ready for multiple linear regression. So that's all about today's session. Linear regression we have studied. All of you just signed your attendance, which is shared in the chat window. Yes, I think you will get this particular notebook for reference purpose. So once we upload the study material, maybe today or by tomorrow, you will get the material. Yeah. Any other doubts so far? Yes, the dependent variable is always going to be on the y-axis. Just a moment, guys. So, Himawant?
Yeah, yes, Mobile.
Yeah, so we can end the meeting in 2 minutes. One more thing, guys. Tomorrow there will not be a session. Friday is a week off for me. So next session will be on Monday. Okay. So next session will be on Monday, guys. Sejab is saying that if we have multiple input variables, then how we will plot the regression plot. As I said, creating a regression plot is not the main task. Okay. So in that case, maybe you will not be able to plot regression plot. You need to plot partial regression plot. So in that case, what will happen? You will create multiple plots. So x1 with y, x2 with y, x3 with y, and so on. So that is called as a partial regression plot. Partial regression plot. But that's not the main objective to construct the graphs over here. Main objective is build a model, use it for prediction. That's it. Yes, you can consider so. Okay. Kunal, I didn't get this question. Like how to find domain from the column. I'm not getting domain means. Nabil Sheikh, it's not the multiple plots. It is called as partial regression plot. Yeah, so multiple plots will be generated over there, but the name for that function will be partial underscore reg plot. So you will get the partial regression plot of y with respect to every input variable. So if there are multiple input variables, you will get multiple plots created. Okay, guys. So let's end the meeting for the day.